Do you remember the robot mower I repaired in a previous video? If you don't remember, you should subscribe to my channel to see more interesting videos and repairs. Well, it sits there since yesterday to recharge, and yesterday didn't do much job. It said it is too tired and it's dark and cold and he wants to turn back to base to recharge. Well, it has a fancy application which works on Bluetooth. See here. Connected, and bam, 47% charging since yesterday. That's bad. Got it to mow and it's a 31% battery. %30 now. These fins here in front of it, I believe they are too low and they are catching on everything. They are too sensible. Those make the robot too sensitive to every little imperfection in the ground. Well, the mower is on charge since yesterday, and look at the battery level. 36%. So the battery is absolutely dead, and this is why the previous owner discarded it, I believe. So I have to take it apart again and replace the battery, which is fairly expensive, and I don't know the model and the voltage of the battery, because even if I took it off previously, I'm stupid and I forgot, and I didn't even took a picture of it. Okie dokie, let's measure the voltage of the battery right now. Around 15 volts. Okay, without further comments, let's take it apart. Simple as that. Let's unplug these cables. Put this shelf side. Since we are here, let's measure this battery too. 3 volts. Still okay. And that's the battery. It's a 20 volt 2000 milliampere hour battery, yard force original one. So from 20 volts we only measured 15. As I said in the previous video, I already opened it up and couldn't find anything funny with it. It was deeply discharged and I charged it and it appeared to work, but it obviously, this is the reason why the former owner discarded it. It has a battery management system here, which is very important because it balances the charge on every little battery here. Let's measure for fun the cells. Let's see if we have any funny reading. We should have around 3.7 volts. This one 3.5, 3.5. So they are fairly balanced, of course. But if we do the math, (3.5 times 5) we should have around 17 volts. Let's see what we have in reality. Yes, indeed, 17.6. of course, instead of 20, after more than 24 hours left on charge. And as you can see, here we have 4 wires. Black and red is the actual output voltage, and the other 2, white and blue, are a temperature sensor, which is used to monitor the temperature of the battery, because when they are charging they heat up a lot and you don't want them to catch on fire or to explode. So if they heat too much, the charging is stopped. So I expect here to have to not have a voltage. Indeed, I don't have a voltage. And then another idea suddenly struck me like a cold beer in a hot summer day. Look what we have here. We had a perfectly functioning working battery, which is precisely 20 volts. Yes. And if we look carefully, it has 2 amp hour, exactly what we need. Let's try this battery and see if it charges. So I'm going to plug this thing in like that. Is it charging? This LED here says it's still working, but I have to check with the app and see if it's charging. And fantastic, look at this. It is charging. It is charging. I'll come back after 15 minutes or so and see if the voltage really increases. Now it's 90%. Yeah. Crazy idea. I've let it mow like that. With the battery attached with wires. Right now it says 17% battery, which I don't believe it's accurate. It should have been more. But anyway, it's mowing for, I don't know for how long, maybe an hour. So it went back to charge until the next day. So after 24 hours of charging, look at the results. Very disappointing. It didn't charge at all. So sadly it's time to go back to the workbench. The battery is not charging. Why is the battery not charging? I want to know. Yes, so in my opinion, this battery pack actually is not dead. It's just not charging. The charging circuit inside this machine is not working properly. The cells are fairly identical, are very well balanced. If one cell would have been bad, I would have picked it up when I measured it. So why is the charging circuit not working properly? I can test that with a multimeter. So I'm using my bench power supply to 24 volts and I'm connecting it here at the charging port of the machine. So right now the machine thinks it's connected to its base and it's drawing very little ampere, about 5 milliamperes, and it is powered up. But let me see if I have some voltage here at the battery connector, like it should be charging. Black and red. Absolutely no voltage here. The voltage doesn't go to the battery. If I measure it, it has 17.6 volts. So if I plug it in, the voltage should increase. Let's see the voltage. What voltage do we have? Right there. It has a varnish and it is exactly the battery voltage. It should be a little bit higher, isn't it? So the battery is not really charging. Basically, you have the voltage going inside the machine. No over voltage to charge the battery. I will take a closer look at the board and try to identify the charging circuit. This is the battery connector here. So the input voltage comes from the front, from here, through this cable here, right there, and it is soldered right there. There, okay. I want to get rid of this glare. Maybe. So it comes here, negative and positive. This is the battery connector where it is soldered. So this is the negative, and it's hard to measure through this covering varnish and conformal coating, as it is called. It is very well coated with the varnish, and to prevent it from rusting over the humidity and weather. But it's very hard to measure something, and I'm using these needle pointers on my measuring leads, and I've noticed that the minus goes straight to the connector. You see? But the plus doesn't even, obviously. So the regulation of the charging is done through the plus circuit. So the plus circuit, if we follow the traces, it goes to this capacitor for smoothing, obviously, and from here it goes over there through this MOSFET here, over here, buggers here, then through this MOSFET over here, right there into this inductor, through this inductor here, and this is another capacitor for smoothing, then here through this diode, and those diodes are in parallel, here at this soldering joint. This soldering joint is the on-off switch of the battery, because this device has the possibility to switch off the battery. This is the switch, the on-off switch. Now is in on position, off, on position, let's leave it on. To disconnect the battery from the board when you store it over the winter. Let's go back to the analysis. Through these diodes, through this switch over here which shorts these pins, and bam, to the plus here. Alrighty then, let's power it up here at the front and follow the electrons and see where they are going loose. For this I'm going to use a more primitive but more robust power supply over here. Power it on, set it to almost 20 volts as the original charger gives us, and connect the plus, alright, and the minus. Boom! The machine started, because we want to measure where the electrons are going. Let's put it on short, and then let's zoom in a little. This glare is very annoying, but still. Alright, well, I said that the voltage is coming here minus and plus, and we should have almost 21 volts, 20.95, alright. Then I said it buggers off here at this capacitor here. Yes, it does. Into the source of this MOSFET, yes. And to the drain of this MOSFET. Not at all. it's not going through this MOSFET. You see the charging voltage, and those MOSFETs here are commanded by a charging circuit, which I couldn't identify here on the board. There is a charging circuit, there is a chip dedicated to charge the battery. Could be this one, could be this one, but I doubt it. I don't know what it does, but it's too complicated to be just a charging circuit. They are PWM commanded, pulse width modulated, such the voltage is regulated not to exceed the maximum charging current of the battery, because those batteries are drawing a lot of current, and if you don't control the current, they will overheat and catch fire. And this is a big problem of lithium batteries. They catch fire, and the fire is very violent. So I'm going to trace again the voltage. So voltage comes here, then it doesn't move, it doesn't cross this MOSFET, and obviously doesn't get into here, and not on this inductor over here. And the inductor and the capacitor has the role to smooth the pulses generated by the MOSFETs. And then we have those two diodes which prevent the current to flow back into the charger if the battery is connected and the charger is unplugged, for example, and the battery will power somehow, would feed back power the charger. So these are the two diodes. I'm going to draw a circuit to make it more comprehensive. So the circuit looks like that. We have the plus coming in and the minus from the front of the mower. Then I have a MOSFET. I make a simplified diagram. Then another MOSFET, then an inductor, then a capacitor. These gates are buggering off somewhere, and they are pulse width modulated. Then I have two diodes in parallel, and they are in parallel because they must withstand a big current, so the current is split through these two diodes, and they are not burning. Then there is the battery. So basically the charging stops here. The MOSFETs are not open, so the current doesn't flow. Let's see if I connect the battery directly to the charger, how much current it draws. It draws a lot of current. Let's make this test just for fun. I power up the power supply, connect the plus to plus, and we have the possibility to set the maximum current. So I'm setting a very low current where the power supply will enter the constant current mode, and let's touch it briefly. So now it draws 1 ampere and at 18.5.67 volts. If I increase the voltage a little bit, so for this kind of battery I don't have to exceed 2 amperes. So let's increase a little bit the amperes to 2, maximum 2. So maximum 2 amperes is 19.2 volts. Okay, let's make a drawing. On the other hand, this battery has 5 cells. The maximum allowed voltage over a cell is 4.2 volts times 5 equals 21 volts. So 21 volts is 100% full capacity. The nominal voltage of one cell is 3.7 volts times 5 equals 18.5 volts, which is roughly 50%. So our battery is below 50%, and the lowest voltage we can go with this cell is 3 volts per cell. We should not go below 3 volts per cell, otherwise this battery life will be dramatically decrease. So 3 times 5 equals 15 volts, which is roughly 0%. So taking into account that the maximum voltage we should charge the battery at is 21 volts, I should give up my original charger, which is 24 volts, and search a maximum 21 volt charger for the battery if I want to bypass those MOSFETs and charge directly the battery, which is absolutely not recommended. But because I cannot identify where the charging circuit comes into the gates of these MOSFETs, I spend more than an hour searching over this board, which is very complicated, and it is multi-layer board and not double-sided. It is multi-layered. It has layers in between. It is very hard to trace. This conformal coating prevents me to measure accurately, and it's very hard to identify the charging circuit. So for now I just decided to bypass those MOSFETs with not directly a short circuit but with a resistor. Because why I would do that? I would put a very low value resistor, about 1 ohm, because it will limit the charging current of the battery. The more current the battery draws, the more voltage drop over this resistor here, so the battery will not overcharge or overheat. The heating is the most dangerous part. So in order not to exceed 21 volts maximum voltage over the battery, I must not input more than 21 volts here at the input. So I search in my power supply bin for a power supply, but you see I have a lot of supplies rescued from laptops and stuff, and I couldn't find a suitable 20 volts as I wanted to, but I found this one, which is 19.5 volts and definitely good enough, 3.3 amperes. Because I have a 19.5 volt charger, I am very safe here. The battery will never be 100% charged, but will be about 90-80% charged, which is fine for me if it works like that. And the more the battery charges, the less current it draws, the less voltage drops over this resistance, which tends to go to 0. So the most part of 19.5 volts goes over the battery, the more it charges. So in the end, when the battery is mostly charged, it basically will trickle charge. This means that will stay under a voltage, but actually it will draw very little current. This is called trickle charge, and those battery lithium polymer batteries are very good at trickle charging. So let's do that. Oh, one more thing, because as I said, the danger of overheating the battery is very high because they catch fire, and the fire is very violent, and it not only it destroys my mower, but the fire can spread, depends where the mower is, to my workshop or to the house even. So what I'm going to do, I'm going to insert in a series with the charging battery a thermostat. This is a thermostat, a 40 degrees 5 amps switch, and it is normally closed, and when the temperature goes above 40 degrees it will disconnect the battery. So this will prevent the battery from catching fire. Let's do that. So this is the 1 ohm 20 watt resistor. It's a big one. I couldn't find a smaller one in my bins, a smaller in size, not in value. So I'm going to solder across those MOSFETs. Man, it was so hard to solder those things. The original solder has such a high melting temperature. Anyway, let's move on. Are you ready? Yes, you are. I'm not so ready to power this thing up and see if I blew anything. Yes, it powers up correctly. Good. I didn't break it. It's not heating up because it has no reason. And it's 20 watts, so it's hard to heat this thing up. But let's measure if you have voltage here at the battery. And yes, we have 18.1. All right. The rest of the circuit, the diodes and all the things are good. Oh, it's actually very well. To 19 volts, roughly. Okay, take it out. Actually, I have to cut this wire here. So basically what happens next is, because you bared with me so far in this video, I want to spare you the boredom and me the embarrassment. I installed the thermal switch in the battery, but it was normally open and didn't work, so I found another one normally closed. I know it's probably an overkill, but since I modified the charging circuit, I don't want to take any chances of catching fire. Moving on. Contraption, and this one is the type they used in kettles or coffee making machine, and it allows the current to flow and the heating element to heat up, and if it heats up too much, it intervenes and disconnects the circuit. The board powered up, so we are good now. Let's connect the charger again. Yes, and it draws 0.5 ampere, which is very good in my opinion. Okay, let's wrap this thing up and make it work again. And since I'm set on repair, I also want to reverse the blades over because they work both ways. So it was like that, and I'm reversing simply just like that. And it will take 1 year for one side and 1 year for the other side. So you can keep the blades for 2 years in my opinion. Then you have to buy another one, another set of blades, which is not that expensive. And you can actually see how small the blades are in reality. As you saw, these fins in front of the mower are too low and they are catching in everything. If the grass is thicker, not longer, thicker, they're interpreted as an obstacle and the mower stops and turns away. If there's a very little bump in the ground, these fins catch it, the mower stops and turns away, and thus prolonging the time it takes to mow the lawn, or it mows inefficiently. So I'm going to shorten them just 1 centimeter. And there is also some fins here I want to shorten. Now, the moment of truth. $19.8, perfect. Take out the old charger and put the new charger back in. Turn the battery on. Yes, it started. And let's see what the app says. It's charging 35%. I'll come back in half an hour and see if the percentage increases. Yes, let's see 45 minutes later what the application is saying. 42%, look at that. Yeah, amazing. So it charges. Wonderful. Lesson. And like the instruction says, those two LEDs should flash when the mower is charging. So it's really charging, and I never saw that before. It's good. I let it mow, then I'll let it charge for a while. Yeah, get out of here. And look at those fins are no longer that deep in the grass.
I know that you are waiting for a conclusion since about when this video started, and here it is. It went to charge at 22%, and the next day it topped out to 64. Actually, it reached this in 4 or 5 hours. Not over amazing, but good enough for me since my lawn is fairly small. At least it charges, and maybe if I increase the supply voltage it would go higher. But I won't do it for now because it's safer. Thanks for watching, and I will see you in the next one.